This is my latest video where I showed off my Retro Tea Breaks book, which is a book written by Neil at Retro Man Cave. And I backed the Kickstarter and I got the book, and I also got some collector cards. And Neil actually commented on my video, and at the end of the comment he says, "Also, you may notice that the cards have a little secret in them." And I hadn't looked at the numbers before that, but I definitely saw that there was some binary numbers, but I thought it was just to be, for the cool graphics. But there might actually be some secrets in there, so that's what we'll have a look at. So this is one of the cards. This is card number 1, Andrew and Philip Oliver. And as you can see, you can make out the numbers, and you can also make out the numbers underneath the graphics there. I don't think the actual pixel art is translucent, so it's only the white part and maybe the red. I'm not sure, but it's very hard to see through the red. But then on the back side we can see more of the binary numbers. It's the same case with this logo. It's kind of easy to see it through the white background, but not so easy on the red. And there's also some text here, art by Stu Cambridge, which is also covering some of the binary numbers. But anyway, this is what we have to work with, and the text, the encoded text here is probably not it's probably shorter than the whole page, so it's probably gonna start repeating somewhere. So we might be able to, even though we can't read the codes here, they might be down here as well. So let's see what happens. I'll scan this on my scanner, and we'll have a closer look at the PC. This is the scanned copy of the card after I cropped them and cleaned them up. So we have both the front and the back here, and also just took the back into its own image, because I think it's the back we're gonna have most luck with getting all the codes, all the binary codes, or binary numbers. That's what it is. And actually on the scanned copy, it's actually kind of hard to see the numbers behind the graphics, especially on the front side, but also on the back side, because you get these artifacts from scanning. But we'll see what we can do about that. We can also make some adjustments, like we can go black and white, and we can change brightness and contrast until we get like a nice, basically black and white image, and just tweak them until we have like some clean characters, something like that. And then we can also invert the colors there, so it's even easier to see the binary numbers, but it hides the numbers behind the graphics though. We'll see. We can definitely do some tweaks there if we want to. So after scanning the card and cleaning up the image, my next step is just to use a binary to ASCII text converter. So I just googled binary to ASCII, and it's basically the first site I found. So let's just type in some binary values and see if it's actually ASCII text. That's the first 2 lines of the ASCII numbers on the card. So let's just hit convert and see what happens. Oh, yeah. So we can actually see that this did decode to some ASCII text. This it was. So I guess we can just keep continuing typing these binary numbers into this converter and see if we can find the rest of the text. Has 2 more lines entered, and this is getting very old very fast. It's kind of hard to read and type this at the same time, and it's also hard to keep track of where we are. So, but let's do the next 2 lines and see what we get. That looks readable, so I guess I didn't do any mistakes. So now it says this was not design. But after doing this, I am a computer programmer, and whenever I do stuff like this, I'm thinking there's a better way to do it. I'm not going to do it manually, because it's a lot more fun to do a lot of manual labor to make something else be done automatically, which makes a lot of sense, right? So that's what we're going to do next. We're going to find a way to do this extraction and conversion from the image automatically. There's definitely a lot of ways to do OCR and extract text out of images, but the first thing that came to mind for me was Microsoft Azure and their Cognitive Services, which includes computer vision and extract rich information from images and video. That's exactly what we want to do, right? So I have a little bit of experience with Azure Cognitive Services, so I'm just going to use them. And if we scroll down, you can see text extraction is one of the features. And we can even choose an image here. And if we do read text, there we go. We actually get a preview of the text in the image. And this is the JSON representation that's given from the Cognitive Services API. So I think we can work with this and try and make an application that's gonna extract some information for us. So my next step was to just find a quick example on how to use this API, and I just did some Googling and I found this: Quickstart, extract text using Computer Vision 3.1, REST API, read operation, and C#. So I basically took this sample code here and I pasted it into a new solution in Visual Studio. And that's going to be my starting point for this project. For us to use the Computer Vision API, we have to create a Computer Vision resource in Azure. And I already did that. It's easy. You just click on this link and it asks you to log in to Azure portal and stuff like that. And then just create the resource. And there is a free tier, which gives you, I think it's 20 calls per minute and up to 5,000 per month. So I just made a free tier Computer Vision resource, and I'll get my key and endpoint from the portal. And this code takes the key and endpoint from some environment variables. We can set those easily. So I just made a Visual Studio solution and I created a console app project. I pasted the code from the Quickstart and I loaded in the scanned image that we scanned earlier. And I've just hard-coded the image. The path is somewhere in here, up here, yeah. So just hard-coded the path to the scan we made. And this is going to be our proof of concept to see if we can extract some text from the card. So let's just give it a go. So this is the response we get from the Vision API, and as you can see, it finds the numbers quite easily. And I checked with the numbers on the card, and actually they are read out perfectly, at least for the first 6 lines here, because those are not being obscured by the graphics on the card, well, on the back side of the card. But then it's having more issues down towards the middle, and you can see that it actually reads some of the words there as well, like brakes, retro. It's definitely a good proof of concept as we get some of the lines out. And if we look at this text towards the bottom here, that is a cleaned up version of these other data up here. So I basically took all these lines that is spat out in the beginning of this, and I tried to clean them up with some easy rules that I came up with basically. And if we scroll down further, we will see the ASCII text created from this binary string. And there we go. Dizzy was not designed as an egg. But then we have some gibberish and yeah, Disney this time, not design. So it's definitely repeating like we thought it was. But this is a good start, so this will be our proof of concept, and we'll try and improve the results somehow and make this a lot cleaner. So after spending my Sunday on this, I have created a RMC Decade Retro T-Brakes Collectors Card Decode Tool. And I don't know, it looks cooler than the console app anyway. As you can see, I've stolen some art here, and I hope that's okay. We have this big area here where we can drag and drop a card, and when we do that, I will show the image of the card. We have a big nice button, run OCR using Azure Cognitive Services, and that's going to populate this text box right here with all the binary numbers, nicely formatted in 5 columns, just like on the card. And we'll see each binary number and like each line in this text box here decoded as ASCII. And we'll see the whole ASCII string as a result down here. And if I just start this, you can actually just, we can also just type in binary numbers here. So don't actually have to do the OCR if you don't want to. You can use this instead of the web tool I used earlier, basically. So let's just try and put in some of the same numbers here and see how it works. You get the point. So this will be our text from the card, and it will show us every character, because every 8-bit is 1 byte and 1 character is 1 byte. So for every line we have 5 bytes, and each 5 of this corresponds to 1 character. And I have been saying ASCII in this video, and I was using an ASCII binary to ASCII converter in the beginning, but we're actually dealing with UTF-8 or something similar here, because there are definitely in some of the cards there are definitely some characters that's outside of the normal ASCII code table. So I actually had to do some changes in my code to allow for that. So far all we have is like a fancier version of the web tool I was using in the beginning. So let me get one of the scanned cards, drag them into the application, and we'll see what happens when we do the OCR. So here we go. I have the Collectors Card Decode Tool open, and I have a scan of this is the back side of card number 1. So we'll just drag that into the tool, get this nice preview, then we click the button. There we go. It's showing the results from the Azure Cognitive Services. I have drawn out the boundary boxes for all the detected lines, and I've also drawn in the text that corresponds with each box. So we can see now that we have the same text as earlier. Dizzy was not designed as an egg. And then we can clearly see where we have issues, because this logo is basically messing up the OCR, and we don't get any good results. And it's struggling to find the text behind the graphics as expected. But at least we have a nice output here, which is strictly binary numbers. So we removed all the other text and stuff like that. But now we have a good starting point. Instead of typing all of the numbers ourselves, we can just go into this editor and we can make some changes manually by looking at the card and fixing some errors. So let me just do that. Okay, so that was still a struggle, and it's really hard to look through the logo on the card, but I managed to do it eventually. And it says Dizzy was not designed as an egg, just as a big face. So not quite automatic. We had to do some manual work as well, but it was still fun to make this tool, and it's kind of fun to be able to extract just the correct binary numbers and remove all the noise. And some smarter people than me can probably do a better job of decoding these single letters, single characters there. But it's still gonna miss stuff in the middle. So I think maybe I filter out too many binary numbers now, but I don't think it would help us much in the end. Yeah, but I'm not sure. There is definitely some smarter people than me out there that can do a better job than this. So I put this on my GitHub. If anyone wants to have a look, try it out themselves, or improve it, or whatever. Just if someone else wanna waste more time on this than I already did, you're welcome to do so. It's currently a private repo, but I will make this public before the video release. And I did also upload a release here. You can get a binary compiled version of the program here, and it should be runnable with no issue on a Windows computer. But it is using my free Cognitive Services key, and it does have a limit. So if a lot of people use this for some strange reason, then we will have issues. And I may also just revoke the key and create a new one at any point. So if you want to use this or improve it and do some testing yourself, you should clone the repo and just create your own Cognitive Services resource in the Azure portal and use your own key. I hope you are okay with this, Neil. I did steal some of your artwork, and I also put a copy of the number 1 card in the repo here. But I'm not gonna decode all the cards and take all the fun away. So just get decoding.